During this session, we'll be going over topic area 1, reactor development and plant optimization. John, could you get us started with some opening remarks?
Yeah, thank you, Joanna. Welcome to the 2026 description of our projects, Q&A. Of course, we're trying to do some catch up here and get everything out so that you can submit proposals for 2026. The outline is given up on the screen now for what we're going to be addressing today. And we first want to thank DOE for supporting this project, NEUP again for this year. We're excited. Things are moving rapidly now. We hope all results from 2025 will eventually be awarded, with hopes up maybe one program this week and maybe another one before the end of the year. So we're doing this. We're trying to catch up as quickly as possible. There's a learning curve associated with any new administration. And so that's really what we're doing right now. So pleased that you're with us. And as we go through the presentations today by our excellent program managers and directors, office directors, we'll have a chance for Q&A and to answer the questions that you might have. Also, those questions and answers will be displayed on our website. Again, thank you for being with us today. And I'll turn it back over to Joanna, unless Aaron has made it on to the presentation.
All right. Good morning, everyone. I am Melissa Bates. I am the Office of Nuclear Energy's Federal Program Manager for our Advanced Small Modular Reactor Research Development and Demonstration Program. I'll get into my program a little bit later. But for this morning, I'll be covering for Janelle Edens. She sends her regards. She unfortunately had a conflict she couldn't avoid. And so we'll be covering the Office of Advanced Reactors, or an overview of it. The Office of Advanced Reactors supports the research, development, and demonstration for both light water and non-light water advanced reactor technologies. Go to the next slide. And so over the course of this presentation, or this quick overview, we'll be covering the different programs that are part of this office. The first one I want to start with is the Advanced Reactor Technologies Research and Development Program. This is one of our non-light water reactor programs. And the program performs research to support the development and commercialization of innovative non-light water reactor concepts. And we do that by working with external stakeholders such as national laboratories, universities, industry, and other federal agencies like the Nuclear Regulatory Commission, Department of Defense, as well as other international entities. There are 5 focus areas within this program, and we will touch on each of these over the next few slides. So the first slide that will go is, I'll turn it over to Kat Abbott to go ahead and introduce herself and to cover a high-level overview of her program.
Good morning. My name is Kat Abbott. I'm the Federal Program Manager for the Fast Reactor Program within ART. So just to kind of go over the mission of the Fast Reactor Program is really to be able to reduce regulatory hurdles as well as increase the technology and development available to private industry in order to be able to develop and deploy fast reactor technology domestically. So our key licensing issues right now that we're focused on are really our safety analysis methods and modeling, our validation and knowledge preservation, since we do have quite a bit of experience in fast reactors in the States, as well as fuel qualification. So any specifically what we're looking at as well for a number of these, what we're looking at for a number of these is would also be kind of if there's interest in working with existing codes. So that could be, for example, on the safety analysis, the SAS or SAS 4A codes, if you're familiar with those. I'm happy to answer other questions, as well as Bison, etc. For the cost reduction, which is another one of our mission goals, we're looking at a lot of design and component technology as well as advanced materials. We have at Argonne National Laboratory, as part of the program that is also funded under the NRIC program, the metal facility. It's the Mechanisms Engineering Test Loop. This is it's been operational since September 2018. It's a 750-gallon sodium loop that has 2,840 liters of reactor grade sodium with 5 operating test vessels, as well as process piping, connecting everything, an expansion tank, a dump tank, and a purification system using a cold trap. We do highly encourage that people, if you're looking to test components or test different materials, etc., we do have opportunities for folks to test their materials or their components, sensors, etc., within metal. So if you need a contact in order to reach out to there for an application or anything, please let me know. My information should be included with the other project managers. And then finally, we've got our fast reactor working group, basically that we do work very closely with industry partners. So if you are also looking at doing a collaborative proposal with industry, frequently we have partners that we connect with there as well, in order to, they also will use the metal facility. Yeah, so we're focused a lot right now on kind of the component technology, decreasing the cost and addressing licensing issues. I'm also the program manager for the Supercritical Transformation Electric Power Program. So this is our supercritical CO2 Brayton power cycle work. The goal of this work is, of course, to be able to prove that we can operate a supercritical CO2 Brayton power cycle. Right now, there's ongoing work at Sandia National Laboratory. We have a test rig there that is currently operating on a recompression closed Brayton cycle, as well as a 1 megawatt loop that's currently about 40% complete, that anticipates being completed and ready for testing by August of 2026. There's a number of different applications for SCO2 in nuclear as well as in industrial power, heat generation, and looking at trying to increase overall efficiency as a replacement for or a substitute for a Rankine cycle. So this is kind of, if you have specific questions about this, I know frequently one of the areas that tends to come up a lot is bearings and seals. We have done quite a bit of work in that area, so if you are interested in putting an application in one of those areas, please go ahead and reach out to me so that we can ensure that we're focusing on work that we have not already been able to test and validate in-house. But we're definitely very interested in that. The other area that we would be particularly interested in for STEP is also integration with other energy technologies, so that includes nuclear, in terms of being able to kind of make that jump from having it be an island to actually being connected. So I believe that's all. Thank you.
Great, thank you. With that, I'll pass things over to Matt.
Good morning. My name is Matt Hahn. I'm the federal manager for gas-cooled reactors. High-temperature gas-cooled reactors most often use helium coolant, triso-coated particle fuel, and a graphite core structure, which serves as the neutron moderator. Operating temperatures in the range of 750 degrees C or even higher enable high efficiency for electrical generation, and even more importantly, the coupling of nuclear process heat with industrial applications. Our current research areas under the ART program focus on graphite material qualification, ASME code qualification of metals for high temperature service, and the use or generation of validation data sets to improve the computational capabilities that support licensing and economics improvements. The graphite area specifically has produced a wealth of graphite irradiation data that's available through the Idaho National Laboratory website. Also, there's links on the GAIN website. We have the natural convection shutdown test facility at Argonne National Laboratory, which provides validation data in support of passive decay heat removal systems. The these are just some examples of some of the work we are doing, and proposals would certainly not be limited to those topics. Given that we have little domestic experience for commercial gas-cooled reactors, there are a lot of important problems, not just for designing the reactor, but operations and maintenance considerations, inspections of components, and other components in the system, including heat exchangers and turbo machinery. We also have limited experience from the technical and regulatory perspectives for coupling nuclear heat generation with non-electric industrial applications. As such, these are all potential areas for further investigation. Thanks.
Great, thank you. So the next area is the molten salt reactor research program. And this is a program that Janelle is currently handling herself. And so I'll cover this one as well on her behalf. So the molten salt reactor campaign, they support two different variants of molten salt reactors, one which has the fuel dissolved in the coolant and the other variant which has a solid triso fuel. Both of these types of reactors operate at high temperatures so that they can be used to produce process heat for industrial applications. In this campaign, they're focused on investigating fundamental salt properties and developing infrastructure, materials, models, fuels, and fuel mass accountability for these reactors. One high priority area is corrosion testing. As you can imagine, the molten salts are pretty corrosive. To enable this goal, we support operation of liquid salt test loops at the Oak Ridge National Laboratory, which supports dynamic experiments in flowing salt. We also largely focus on measuring thermophysical properties of a wide variety of molten salt to support design and licensing of these technologies. So the next topic area will be microreactors. Over to Diana.
Hi, good morning. My name is Diana Lee. Can you hear me okay? Okay, great. So I'm the microreactor program manager in NE52. And I'm just going to give an overview of what we are focusing on in our microreactor program. So the microreactor program is focused on leveraging cross-cutting research and development activities in collaboration with our national laboratories and universities to achieve technological breakthroughs for key features of microreactors. This would help in reducing risk and time needed to deploy advanced nuclear technology, improve our economic viability and licensing readiness, and enable successful demonstration of multiple domestic commercial microreactors. The activities in the program are organized into 4 technical areas. The first is system integration and analyses, in which we identify the needs, applications, and functional requirements for microreactors through market analyses. And this technical area also includes investigation of microreactor supporting capabilities such as modeling and also research to help develop the regulatory basis for microreactor deployment. Our second technical area is technology maturation. And in this area, we have research into advanced materials such as yttrium hydride and zirconium hydride for high temperature moderators. We're also investigating heat removal technologies such as heat pipes, heat exchangers, and deployment of sensors. And this technical area is also where we have demonstrated a microreactor startup sequence utilizing MAX, which is our microreactor autonomous control system. And this helps us to adapt and apply technologies for monitoring and controlling microreactors. The third technical area is demonstration support capabilities, and this includes our non-nuclear testing capabilities such as SPHERE, or single primary heat extraction and removal emulator. This facility allows us to test heat pipes primarily and gives us the data to allow us to validate performance of heat pipes. Within this technical area, we also have MAGNET, which is our microreactor agile non-nuclear experimental testbed. This testbed allows us to simulate core thermal behavior and heat pipe and primary heat exchanger performance and decay heat removal. And in the last year, the MAGNET team has been working to integrate a gas Brayton cycle power conversion unit, as well as a graphite test article with heat pipes. Then we have our fourth technical area, which is microreactor application. And the main focus in this area is the MARVEL, or Microreactor Applications Research, Validation, and Evaluation Reactor. let's see. Next slide, please. Oh, so this is our Marvel, a mock-up of what our Marvel reactor could look like within the treat building at Idaho National Laboratory. Marvel is meant to be a very small microreactor utilizing high assay low enriched uranium TRIGA-like fuel. It will use natural circulation of sodium potassium and 4 control drums, as well as a central insurance absorber or control rod. As part of the development of Marvel, microreactor industry can benefit from activities that we've already performed, such as demonstrated use of an environmental assessment, which took approximately 6 months to develop, as opposed to environmental impact statement, which could take as long as 2 years. As part of the development of Marvel, we've also helped to reestablish reactor design, fabrication, and demonstration capability at Idaho National Laboratory. And in the future, hopefully near future, we're hoping to demonstrate Marvel with end user applications. So on December 4th, the Marvel team announced the selection of 5 commercial teams that would potentially demonstrate advanced applications. This includes data center integration, sensors, water desalination, and remote operations. So for this NEAP scope, anything that could help support our mission and accelerate our mission, that will be what we're looking for. Thank you.
Great, thank you, Diana. Right, so the next program is the Advanced Small Modular Reactor Research Development and Demonstration Program. So this is the program that I'm the federal program manager for. And under this program, we really focus on the research, development, and demonstration of small modular reactors. At present, we seem to be focused more on light water reactor technologies within this program than non-light water reactor technologies, but that can also shift over time. And some of the key things that we are really focused on are trying to find appropriate improvements, to improve the cost effectiveness or reducing the size of the small modular reactors. At present, a large percentage of the work is focused on working with industry to support their efforts to develop and deploy reactors. And so it's largely through cost-shared partnerships with those entities. We're also working to enhance the domestic supply chain and try to focus on some of those critical gaps for the supply chain that'll be needed to domestically produce the items that would be needed for a future SMR order book here in the near term. And so by near term, we are usually focused on like a first deployment in the very early 2030s, like by 2030 or 2032, around there. And then we're also focused on those reactors or small modular reactors that would come in quick succession after that. And so not really yet in a position to look at those further down the road, like towards the nth of a kind, or more than a decade out. So all right, so the next slide is the National Reactor Innovation Center. Savannah Fitzwater, one of our teammates, is the federal program manager over this area. She is also unable to make it today, and she sends her regards. So I'll be covering this program for her as well. The National Reactor Innovation Center, or NRIC, is tasked with enabling and accelerating the development and demonstration of advanced reactors by harnessing the unique capabilities of the national labs. This program currently has work progressing in a few different areas. First, NRIC is working to build 2 different test beds at the Idaho National Laboratory. The first one, called DOME, or Demonstration of Microreactor Experiments. And the second one is called LOTUS, or Laboratory of Operations and Testing in the United States. DOME will be able to test experimental microreactors up to 20 megawatts, and LOTUS will be able to test experimental reactors using high security materials. DOME construction is expected to be complete early next year. The second area that NWERC is focused on is experimental infrastructure, which includes the metal facility that you heard Kat talk about earlier in this presentation, which is at Argonne National Laboratory, as well as the helium component test facility at Idaho National Laboratory. Early next year, the program expects the molten salt thermophysical examination capability, or MISTIC, to be operational. MISTIC will enable the examination of irradiated molten salts and is the only facility with this capability in the US. The third area that this program is focused on is the development of advanced construction techniques to reduce the cost of construction of new nuclear plants, and they have several interesting initiatives under that area. And then the last area that the program is focused on is they are also heavily engaged in the Office of Nuclear Energy's maritime nuclear efforts, which is an exciting, fast-paced area, which includes the development of floating nuclear power plants for a variety of scenarios, as well as vessels of many sizes. So with that, I believe that concludes our presentation or our overview, and I think we can open it up for questions.
The first question is being answered. It will be put in the chat, but the question was, for an R&D project, if I collaborate with a company, do you have a limit for the budget limit to the company? And the limit is 20% of the total requested budget. You can refer to page 16 of part 1 of the NOFO. Next question. Topic area 4 fuels also mentions that there's a need for characterizing and modeling molten salt properties, structure, and chemistry, but comments that fuel salt are in need to be expanded to process chemistry. However, thermophysical property measurements of salts was also discussed for MSRs in the topic area 1. Which topic area would be best for salt property measurements?
So I'll open it up to the team if anyone is more informed, but generally how we split the topics between any 5, which is this group, or any 4, which is the fuels group, is if it's more fuel centric, it would land in the any 4 space. If it's more like how the reactor is developed or operates, then it would be more in the any 5 or more in this topic area. I'm not sure if anyone would want to add further to that answer. Okay, great. I got a thumbs up from Kat. So it looks like we received another question for molten salt property measurements. Do you have a specific salt in mind of interest? Kat, would you by chance know the answer to that?
I want to say chloride salts, but I'm not 100% sure. If you can send that to the staff, then we can go ahead and come back and answer that once we've got our specialist in.
Yeah, that would be great.
I could jump in for a moment if you'd like.
Yeah, sure.
So as Kat mentioned, chloride salts are certainly of interest, and then fluoride salts as well. There's a couple, reactor concepts out there, which use fluoride salts, so that those could certainly be of interest as well. Whether the salt properties themselves or corrosion related issues and things like that.
Next question is, this is about many reactors. So so how many awards are you expected in this technical area 1? John, do you want to go ahead, Melissa.
No, I was going to say, I think that this is more of an EF relevant question as far as how you disperse your funding.
John, did you want to answer that, or would you like me to?
Well, I can just say in general, there are a number of factors that go into how many awards that are made in each of these areas. At least one, for sure, as we divide these up, assuming they're good proposals, excellent proposals in that area. Other factors, of course, include the budget and how the budget is dispersed among the various programs and the need for research in those areas. Also, another factor is how many proposals excellent proposals we actually receive in a particular area. And the panels that judge these will make recommendations as to funding, how many they recommend be funded, and then it's a matter of finding the money to handle that. So it's kind of a vague answer, but at least one will be funded, but perhaps more. Maybe go back and take a look at the funding pattern from the previous set of awards in 2024 or earlier, and you'll be able to kind of get a feel for that.
Thanks, John. Okay, I'll go to the chat. For the MSR corrosion test, does it include developing corrosion resistant coating?
Yes, it would.
Good morning. Can you hear me
Thanks.
okay now?
Yep, we can hear you now.
Well, thanks for the presentation. It's pretty good. I have a specific question, and this is Manish, by the way, from Tennessee Tech University. I have a specific question for Melissa on her slides. She had a keyword with fuel mass accountability technologies. Can you please expand more on that? Are you basically talking about like nuclear safeguards or non-proliferation issues, or cracks in radioactive material piping and things like that?
Yeah, and since I'm covering for a few different individuals, do you remember which slide that was on specifically?
The title of the slide, Melissa, was Molten Salt Reactor Research Program.
Okay, great.
I do not have a slide number though.
That's fine. You gave me enough. Matt or Kat, is that anything that you guys would be able to answer?
I don't have anything to add.
Okay, all right. Just since the team is covering for a few individuals that had a hard conflict, Manish, is that something that you'd be able to send in a question and we can try to get you a response?
That's good, Melissa. Yeah, I'll do that.
Great, thank
Thank
you.
Next question is development of secondary coolants for MSRs and FHRs of the interest to the topic area.
For that question, if you could please send it in. Sorry, it's just Janelle, our lead for MSRs, could not make it today, and so given most of these questions are in that area, we'll need to have those questions sent in.
Is the microreactor specific for Marble or other designs as well?
Diana? Okay.
So the microreactor program is focused usually on cross-cutting research that can benefit multiple microreactor designs. We also do have work that with Marble, so it's not just Marble. So if you look at the different technical areas that we have, things that could help, say, for heat exchangers is one area, because that could benefit multiple different designs for microreactors. So yes, definitely not just Marble.
As we're waiting for other questions, just a reminder that for the CINR R&D pre-application deadline is January 28th. And then if you're doing an NSUF project, those are due on January, or the letters of intent are due on January 5th. Okay, we have another question. Under topic area 1, is there any preference on experimental work or computer simulation work, or both work are acceptable?
I'd like to hear the perspectives of the broader team, but my guess is that would probably be under a different topic area. Probably the one, I believe that there's a topic area that's more suited for computer simulation. It's associated experimental work.
Yeah, I would agree with that. I think make sure that you kind of carefully read the topic areas, all of them, to make sure that you understand which your topic falls into. And if you believe that you have something that's kind of right on the edge, you can go ahead and reach out to the staff and they can put you in contact with us. We can frequently let you know whether or not one belongs in one topic or another.
Yeah, I agree. I don't really have anything to add, but there's probably the name specific area for computer simulation work exclusively. And then for the, for topic 1, I think you can kind of go one way or the other. It's nice to have, projects that have both experimental and simulation components, because that provides, especially from the perspective of students, gives them a lot of good training.
Manish, go ahead.
Hello again. I have another question. This is more a generic question, and this is in regards to page 7 for CINR part 1. And the question is, does the supplemental funding opportunity area, is it an independent proposal call, or that area has to coordinate with the other 3 funding opportunity area given on that page?
Sorry, I'm trying to better understand your question and quickly trying to scroll to page 7.
So basically the title for the funding opportunity area is like supplemental funding opportunity area. And I was just asking that can I just target that funding opportunity area, or that supplemental, meaning it has to be gone together with the other opportunities area that I see from 1 to 3.
Do you want to answer? So Tyler can answer your question. He'll
Okay.
jump right on.
Yeah, so the supplemental funding area, the research experience for undergraduates, that can only be applied as a supplement to a CINR application. So it can't be applied for independently.
Gotcha. Thank
That's
you, Glenn.
correct. That's correct.
So we have another question. Non-technical question. I missed yesterday's portion of the webinar due to teaching commitment. Will the webinar be recorded and made available on YouTube or elsewhere? Yes, it's been available. So yesterday's sessions are already posted on our NEUP site. So we can drop the link into the chat, so it takes you right to those recordings. And we're also compiling all the question and answers. And when those get all compiled and reviewed, then we'll post those also. We really appreciate your time and interest in this call. Thank you so much for attending.